Hello, everyone. Our senior project was about process improvement at V10 Construction. I am Sharaf Al-Hello.
I'm Santiago Mejia.
I'm Naman Sinha.
And I'm Ryan Walty.
Our advisor was Dr. Elias Messian. Here's an outline for this presentation. First, we're gonna start with an introduction. Then we're going to define two problem statements. The first one is inefficient facility layout, and the second, unproductive workstation and storage system. And then we're going to show improvements and cost analysis, and of course, ends with a conclusion. Located in the city of Pacoima, V10 Construction was founded by CPP alumni Dr. Kokorian. They specialize in construction and luxury remodeling, as well as interior and exterior design. Not too long ago, they started manufacturing some products like doors, cabinets, and more. As a company that's new to production, V10 Construction Facility is heavily reliant on random storage practices, random workflows, and an unorganized layout. By introducing an improved facility layout as well as expanding manufacturing to another facility, V10 Construction will be able to increase profits and productivity. One of their biggest problems was being unorganized. So we created a fishbone diagram and broke it up into 6 different parts. These parts are the causes that lead to their low production efficiency.
The next couple of slides are going to cover and summarize some data that we collected, and this will help us with our solutions to our problems and provide quantifiable metrics. Here we have the machine utilization of the company. In this, each machine in the facility is listed as well as a percentage next to it. This percentage indicates the percentage chance that on any given day, that machine will be in use. It's important to note that at the bottom, there are additional machines with 0% usage. This is because there are machines that are inaccessible or even taking up space and not being used. V10 Construction is a make-to-order company. This basically means that they don't manufacture product until a confirmed order is received. As mentioned before, here are the products that they manufacturer. They have cabinets, doors, ACM panels, fence rails, and tiles. Shown here in this graph is some production data for 12 periods. We can see that cabinets are being produced the most, with doors and tiles coming soon after. Shown is a chart of their demand and the orders they receive. The product ordered most by customers is cabinets. This is important to our project as our improved layout that we're going to show later is designed to prioritize products that have the most demand.
I'll be talking about the inefficiency of the facility layout at V10 Construction. This image that you can see here is actually the whole layout of the actual facility, in which it takes up 3 main parts. One, the open area that includes the parking, any other storage that could be used in outside doors. On the left side, that is one building that is mostly used for, that's their main facility, where their office and also where the machinery and storage for manufacture for their construction sites are. On the right side, you can see that it says rented out building, in which is the building that they are going to try to implement into the future in the new facility layout. But first, I'll be focusing on the left side in the bottom left, where it's just focused on the actual production of the materials that they could see. If you could clearly see that the blue arrows are all is the flow of production that goes in the process of making a cabinet and a door. As you can also see that the red arrows are for the tiles, the purple for the MC panels, and then the green for the fence rails and perforated panels. You could clearly see that in a sense when it comes to production, that area on the left side is the most focused, and as well as you can see as it's more disorganized, because any text that is red means that either that machine is not being utilized because they don't have enough efficient space, or they just currently have implemented purchase the machinery. When it comes to the relationships with the machines, we create an activity relationship diagram in order to categorize all the storage and machinery when it comes to production of the actual product. Here you can clearly see that a bunch of the relationship when it comes to machine and storage are used. This to show that much of the machinery needs no relationship with one another, meaning that they can actually be moved more around freely, which gives us an advantage to decide to pick and choose which machines will be moved to the next facility without the fear of consequences of it being like too far from any other production. Okay, here I'm going to point out in a sense we came to the conclusion of what machines are actually going to be moved to the next facility. Here you can see that machine C, B, and D, as well as H, are going to be moved to the new facility. The main reason why we chose these three machines is because one, they need the most amount of space, because you can see that they're close to the very edge of the building, because the forklift needs to be able to go through and have accessibility towards them. And you can see as that machine doesn't have enough space to be utilized to its full potential, because it doesn't have accessibility to the forklift. So the only thing they can use with that machine is to put on ANC panels, but that are be able to be handled by hand. Here we created a more improved facility layout. Like I said before, we chose the three machines because one, in a sense, they need the room, as well as the fact that the office that is right next door has very little like noise cancellation, which affects the efficiency when it comes to workers that work in the office. But now you can see on the left side that all the texts are now blue, means that they have been given efficient space in order to work or be able to work more efficiently. As well, you can see that we created a new workstation called K. We'll be going more detail into it in the later slides, but this is to improve production when it comes to cabinets and doors. Here we can see the current versus improved layout of the facility, in which we can see that the distance score for the overall facility was increased by 9%, while when it comes to the adjacency score, it increased by a whopping 12%.
So I'll be talking about one of the biggest problems that V10 construction faces, their unproductive workstations and storage systems. As you can see in the picture here, their workstations and storage solutions are very unorganized and sporadic. The processes used are all based on memory, and there's no designated markers or placement for finished work or work in progress. As you can see here in the picture, they're even using cabinets that are halfway built to store scrap and be used as an additional workspace. This leaves them susceptible to errors and losing product that leaves them unable to complete orders. Another disadvantage of this system is that the boards are prone to scratches, which makes them unusable for production and leads to waste. This system is also very inefficient for new hires to figure out how the shop works and where everything is located throughout the facility. Here you can see an example of another workstation that is used to assemble the cabinets as they're made. Not only is there barely enough space for the material to build the cabinets themselves, but it's also being used for random storage of empty cardboard boxes and various tools for other equipment. The other machines in the background are also used as storage for work in progress, making them unable to be used for further production. Here on the left-hand side, you can see the location of our improved workstation K, where we have included a space for raw material storage, as well as a workstation for any assembling that may need to be done, storage for work in progress for the cabinets and doors, as well as a designated location for scrap material and finished product storage. You can also notice that there is a big gap through the workstation area, and that is so that a forklift can come in and drop off new pallets of raw material as they are needed. Since they are unable to move into their new location until January, we have suggested an additional 5S steps that they can implement once they have moved, such as signage to designate specific locations for work in progress, as well as other materials needed for production. We also suggest that they create a written set of procedures to follow, so that way they are able to stay on track and keep everyone up to date on what they should be doing. We also suggest that they create measurable standards for operators to compare their work with to make sure that they are doing their job as efficiently as possible and up to the correct quality. We also suggest that they create additional storage for work in progress, raw materials, scrap, and finished products for the other machines that they will be needing to use outside of the cabinets and doors. In order to combat the sound heard by the employees that work inside the office, we suggest, since we were unable to move all the machines out of the main facility, that they invest in sound deadening material that will greatly improve the amount of work and productivity that they are able to accomplish. Another option that they could do would be to have the employees work from home, as that has become a much more popular option nowadays.
We wanted to know if our new improved layout would actually show improvements over the original layout. Using Promodo, we simulated the process of manufacturing some products using the old versus new layout. A significant improvement was observed. For cabinets, previously it would take 25 hours of work to produce a batch of 49 cabinets. However, when implementing our new layout, the time it takes to manufacture the same batch becomes 22 hours. That translates into 14% efficiency increase. We also simulated the process of making doors. Previously, it would take about 103 hours of work to make a batch of 80 doors. With our new layout, we expect them to make that same batch in 101 hours.
In order for this expansion to make sense, they would have to be able to make up for it with product produced. The building that they are looking to expand to is roughly 4,600 square feet, being rented out at $3 a square foot. This gives us a monthly rent of close to $14,000. We found, through the additional production of 24 cabinets or doors, 4 perforated panels or AMC tiles cut on the laser jets, and 4 tiles cut on the water jet, that they would be able to meet this requirement, and any additional product that they are able to produce would be profit. We also found that if they were able to operate under optimal production, they would be able to see profits of north of $100,000 per month.
With shown improvement to the facility layout, storage system, and an expansion to their second building, we believe that V10 Construction can increase productivity and profits while improving product quality and customer satisfaction. A special thanks goes, of course, to Dr. Masahian as well as Dr. Kukorian and David Lopez from V10 Construction. Thank you.
All right, let me stop recording.
Let's go.